Math 1314, Section IC, Spring 2022, Tyler Junior College. Section 1.6, Absolute Value Equations. Video 2, Bigger Absolute Value Equations, as opposed to Basic Absolute Value Equations. Now, what do I mean by bigger? Do I mean bigger numbers? No, I mean more parts to the equation. More numbers, if you will. So here's an example. Let's say we want to solve the equation, the absolute value of 3x minus 1 followed by minus 4 is equal to 13. Well, let's think about why this is different than what we saw previously and how we can get it to a state that we can solve. We know how to solve an absolute value equation, assuming that you watched the previous video, but we know how to solve an absolute value equation of the form absolute value of some expression equals a number. So why is our current state, why is this not that? Answer, this guy has just an absolute value on the left, not an absolute value with more numbers. But this guy has an extra number. Specifically, it's got the absolute value of 3x minus 1, but it also has this minus 4. If that minus 4 were not there, so let's pretend just for a second that it was gone. It's not, but let's pretend it was. Then our equation would have the correct form and we would know what to do with it. So we should probably start by getting rid of that minus 4. Okay, so what can we do to get rid of a minus 4? By now you should know the answer is add 4 to both sides of the equation. So let's do that. And let's see what we get. All right, if we do that, then the 4's cancel. And that leaves us with, and we'll type it down here, absolute value of 3x minus 1 on the left equals 13 plus 4 is 17. And at this point, we've got it down to a basic absolute value equation where we have an absolute value of an expression equals a number. And it's worth noting the number is not negative, so we will get some solutions. Remember what this means in terms of distance from 0. Absolute value just means distance from 0. So if we were on a number line, what this equation is saying is that the expression on the inside, 3x minus 1, has to be 17 spaces away from 0. Well, where would that put it? Well, if it went 17 spaces to the right, it would put it over here. If it went 17 spaces to the left, it would put it over there. Positive 17 on the right, negative 17 on the left. So the thing highlighted, 3x minus 1, has to be in one of those two places. That means that 3x minus 1 is equal to 17, or 3x equals minus 1 equals negative 17. You don't have to draw the number line. You actually don't even have to think in distances, but it justifies the next move in solving a basic absolute value equation. That next move is to rewrite this one absolute value equation as two equations. Put the expression equal to the number and put the expression equal to the negative of the number, giving us two simple linear equations, 3x minus 1 equals 17 and 3x minus 1 equals negative 17. We can solve both of them using the same moves. We're going to add 1 to both sides of the first equation to get 3x equals 18. And when we divide by 3, we end up getting x equals 6. 18 divided by 3 is 6. But on the other one, when we solve using the exact same moves, we'll get a different outcome because the number on the right side of the equal sign was not 17, but negative 17. Still going to add 1 to both sides. This time negative 17 plus 1 is negative 16. And then attempt to divide both sides by 3, but notice I said attempt because 16 won't divide by 3 evenly. And so we're stuck with negative 16 thirds. But that would be our two solutions, x equals 6 and x equals negative 16 thirds. So let's think about what happened here and try to turn it into a plan of attack. The first thing we did was to get the equation in basic absolute value equation form, which essentially meant if there were any numbers outside the absolute value, we had to get rid of them first. So we had to isolate the absolute value. But once we got it there, once we had absolute value of an expression equals a number, as long as that number wasn't negative, we could put the expression equal to that number, which is what we did when we put 3x minus 1 equals 17 right here. And we put that expression equal to the negative of that number. 3x minus 1 equals negative 17. That removes the absolute values, and then we can finish solving. So, how to solve an absolute value equation? Well, this wasn't all supposed to be there for you to see all in its glory, so we will do this and eventually recover everything under it. So pretend it started this way. How to solve an absolute value equation. Number one, if necessary, isolate the absolute value until the equation has the form absolute value of an expression equals some sort of number. I had to fix the typo. But once you get it to this form, once you get absolute value of an expression equals a number, and you may remember why the asterisk is there, what do we do next? Well, then we rewrite the equation as two simpler equations. Simpler equation number one, whatever's on the inside, that expression is equal to that number. And simpler equation number two, whatever's on the inside, that expression is equal to the negative of that number. This removes the absolute values and gives us two simpler equations to solve. But remember, if the number is negative, there are no solutions. So it's pretty straightforward. Isolate the absolute value, set up two equations, unless there are no solutions, and then solve. So we'll take a look at two more. I invite you to pause this video and give them a try. All right, let's begin with the first one. Solve the equation. 2 times the absolute value of 4x plus 1 followed by minus 5 is equal to 11. Well, this is not a basic absolute value equation because the absolute value is not by itself. So our first set of moves is geared towards getting that absolute value that I just highlighted by itself. So we need to concentrate on getting rid of the 2 and the negative 5, or specifically getting rid of the 2 that's multiplied and the 5 that's subtracted. Which one do we get rid of first? The answer is the 5. Since the 5 is subtracted, we'll start by adding 5 to both sides and see what that gives us. On the left, we still have the 2 times the absolute value of 4x plus 1, but the 5's cancel. And on the right, we get 11 plus 5 is 16. At this point, we're a little bit closer to having the absolute value isolated, except there's still a 2 multiplied in front of it. That's an easy problem to fix. To get rid of a 2 that's multiplied, we can divide both sides by 2. That will cancel the 2 on the left and leave us with the absolute value of 4x plus 1. Absolute value of 4x plus 1. And on the right side, we have 16 divided by 2, which of course is 8. Notice at this point, our equation is now a basic absolute value equation. The absolute value of 4x plus 1 is equal to 8. And it just occurred to me that those 1s that I have written inside the absolute value bars do look like vertical lines as well. So I'm going to try to make them look a little bit different than the absolute value bar so that you can distinguish between a 1 and an absolute value sign. All right, but getting back to the equation where we're currently at, the absolute value of 4x plus 1 is equal to 8. We now have a basic absolute value equation, which is the absolute value of an expression is equal to a number. So where do we go from there? Well, remember, in terms of distance from a number line, what that equation is saying is what we're taking the absolute value of, the 4x plus 1, has to be 8 spaces away from 0. So if it's 8 spaces to the right, then we have 4x plus 1 is equal to 8. But if it's 8 spaces to the left, we have 4x plus 1 is equal to negative 8. Both of these are pretty easy to solve, so I'll get right to it. I'll talk it out. On the first one, we would subtract 1 from both sides. 8 minus 1 is 7. Then we would divide both sides by 4 and get x equals 7/4. Make that 4 a little bit better. And on the other one, 4x plus 1 equals negative 8. We would still subtract 1 from both sides, but that would leave us 4x equals negative 9, and then divide both sides by 4, and we get x equals negative 9/4. So pretty straightforward. What about the second one? Let me move it over a little bit. 5 minus 2 times the absolute value of 1 plus x is equal to 13. Well, again, our process for solving an absolute value equation is to first isolate the absolute value. In the second equation, the absolute value is the absolute value of 1 plus x. Let's highlight that. First move is to isolate that. We have a 2 multiplied in front of it, and that expression is subtracted from a 5. So we need to get rid of the 5 and the minus 2. Do you remember which one we get rid of first? A good rule of thumb is to get rid of the thing further away. The thing further away from the absolute value is the 5. Since it's part of an addition/subtraction problem and the 5 is positive, we would need a negative 5 to cancel. Let's not draw those canceling marks. That would leave on the left negative 2, absolute value of 1 plus x. And on the right, we get 13 minus 5, which is 8. Have we isolated the absolute value yet? We have not. It still has a negative 2 multiplied in front of it. Well, I know how to get rid of things that are multiplied. You divide. So we'll divide both sides of this equation by negative 2 to cancel the negative 2 in front of the absolute value of 1 plus x. And on the left, that would leave us just the absolute value of 1 plus x. On the left, excuse me, on the right, we get 8 divided by negative 2, which is negative 4. And now we've got our basic absolute value equation, meaning that we have the absolute value of an expression, absolute value of 1 plus x equals a number, negative 4. And our next move is what? Now, if you said our next move was to put 1 plus x equal to 4 and negative 4, stop. You weren't paying attention to the asterisk earlier. Remember, if you're solving an absolute value equation and you have absolute value of an expression equals a number, and that number is negative, there are instantly no solutions because absolute values cannot come out negative. This equation, in its current state, is asking for precisely that, is asking for the absolute value of something to be negative. That is impossible. This equation actually has no solution. Looks like I hit caps lock somewhere. Again, that's because you're trying to solve an absolute value equal to a negative, and absolute values never come out negative. All right, so this protocol here is essentially what you need to know for this section. To solve an absolute value of an expression equal to a number, to solve any absolute value equation, and I meant to put any absolute value equation here. It's a little pompous because I'm sure I could concoct something that would not be so simple to solve, but for our purposes, to solve any absolute value equation, isolate the absolute value. If the number it's equal to is negative, shut it down, there's no solution. Otherwise, set the expression equal to the number and equal to its negative and solve each simpler equation. And that's all there really is to it.